I'm going to go ahead and start the webinar here. This is Tony Riggs with GoEngineer. I'm an applications engineer out of our Houston office. And we started talking about, what kind of presentation we would do this month. And the idea of running Ultem, either 9085 or 1010, is a little bit different than running your regular ABS material. So I wanted to go over things a little bit. We're going to have some information comparing 9085 to the Ultem 1010. But some of the first questions that I normally get from a new Fortus user is, the process that I normally go through when I do change tips and material. So we're going to go through some of that here in the presentation form. And you don't have to do it my way. There's probably a dozen different ways you can, go through the process of changing materials. I've got it down where I can, change materials and tips, fairly quickly. And we'll talk about some of the differences when it comes to Ultem 1010. So the title here, Hot Stuff, Making the Switch from ABS. I actually printed a part earlier this morning, last night, and took it off the machine about 30 minutes ago. I reached over a few seconds ago, and it's on my desk, and it's actually still kind of warm because the Ultem material does get extruded at quite a lot hotter temperature than the normal ABS that we're used to. So we'll see some of the temperature numbers here in a little bit. But as far as the presentation goes, I kind of broke it up into a couple of categories. Loading and calibrating, some of the steps that I use. Here in Houston, we've actually still got a Fortus 400. Some of you may have a 360 or a 380 or a 450 or 900. Some of the same techniques can still apply for switching materials and keeping track of the tips and the material usage and stuff like that. We're also going to look at pre and post-processing tips for Ultem. The difference between Ultem and say ABS or ASA, besides the temperature that the material can handle, is the fact that the Ultem material only comes with a breakaway support material. So when we're looking at the designs, we want to try to minimize the amount of supports that are difficult to get to. With a regular water-soluble support material, throw it in the tank, the water gets to it and dissolves it away. Here we're going to have to go in and pull the material off. The parts that I've been printing have about a 6-inch hole up through the bottom with a rounded top. There's support material up in there. It's about 3/8 of an inch hole. So I'm going to have to go in and get a long pick or some sort of small drill bit to go in and kind of get rid of that support material up in there because I can't get at it very easily. I've definitely seen parts that people have tried to print in Ultem that you're never going to be able to get a layer or two out between a sandwich of model material. The Ultem 1010 support material is supposedly easier to remove than the 9085 support material. I've seen that some. I still like to go ahead and take the support material off when it's warm. So definitely putting the part back into the build chamber to heat it back up can be very, very useful when removing support material. Once the support material cools, it becomes hard as a rock and very difficult to come off. And I got a couple examples of some parts that we've done, a couple case studies on Ultem parts. So let's look at the loading and calibrating, and we'll see how long it takes to go through some of this. When you're preparing a presentation, hey, I've got 100 slides. Well, how long is it going to take me to get through those? We'll kind of see. I've got the question and answer area brought up on my second screen. So if you guys have any questions, type them in. I'll try to get to them as I go, or definitely try to cover some of them at the end as well. So switching from ABS really between any materials, we've got a couple of things we've got to do with the machines and the tips and the canisters. You know, keeping track of how much material is on the canister and how much material has been run through the tip, and how we go and unload the current material, load the new material, and get things all nice and calibrated. So, like I said, kind of hot, slightly warm. I took this picture during a build, so right now it's currently laying down model material. So you can see that the model is running at 395 degrees Celsius. So for those of us who like Fahrenheit temperatures, I added a little conversion over there on the side. 743 degrees. The oven, where the normal Fortus 250 run ABS is running 75 degrees C. We're at 430 degrees F. So if we wanted to bake some muffins and a small cake in there, that might be kind of good. We actually put some chocolate chip cookies. We were at a trade show, chocolate chip cookies into one of the Fortus machines once. The booth smelled like chocolate chip cookies the rest of the trade show that day. So that's kind of fun. So here's a picture of our Fortus 400. I'm going to throw some other pictures on here and kind of look at the machine and how we would get started. So right now I'm just showing a picture. Hey, I've got ABS material loaded in the machine. Down below on our 400, it's kind of nice. I've got it kind of separated into a couple different areas. In this first cabinet area, this is where I typically keep tips that are currently, or the tip holders that are currently in the machine. Other places where there are tips, I've got them broken up into different types of materials. Okay, so the PC tips here, the Ultem tips here, the ASA tips here, nylon. I've got a place for the manual at the bottom, the large pile of stickers. It's kind of been a tradition of mine whenever I go and put a new canister in the machine, I'll have a stack of stickers. So those are all the stickers that I've currently run through this printer. The 400 also gives us a nice area in the top canister area where we can store additional tips. I've seen customers go through and make tip holders. I've got customers that are going in and have barcodes on their tips to keep track of the material usage and stuff like that. All kinds of different things that people do to keep things straight. So getting ready to switch to Ultem. The Ultem build sheets are quite a bit thicker than the regular ABS or nylon build sheets. They take a little bit longer to heat up. Once they do, they typically pull a vacuum fairly quickly. So if I know I'm going to be switching to Ultem, I'll right off the bat, I'll go ahead and throw a new build sheet in there. You let it start warming up, through the rest of the process. I want to go ahead and gather my tips. So with regular Ultem 9085, you're going to be running a T16 tip for the model and a T16 tip for the support. With Ultem 1010, the T16 is still there for the support, but the T14 is what we're going to run when we're doing a 10,000 slice on the Ultem 1010. So Ultem 1010 will only run, right now at least, in a 10 or a 13,000 slice. Here I got a picture of me going ahead and putting the Ultem canisters in there. Get them rolled up with the thumb wheel ready to go. I tried to show a picture with the lights flashing, but I got 3 of the lights flashing and 1 not flashing. The 2 in the middle are on all the way. They're still loaded, and the model on the far left is supposed to be flashing. So use your imagination, right? So going through and getting ready, we need to keep track of how much material, or I like to keep track of how much material is left on the canister. So that way when I go pull a used canister off the shelf, I know, hey, I need such and such material. This one's going to be able to handle it. I don't have to stick it in the machine to find out. So modeler status, machine material status, and look at how many cubic inches of material are on the canister. I typically then go in and write that on a Post-it note and stick it to the canister. Okay, ignore my sloppy handwriting. We'll go with that. Next type thing, tip usage, because we're going to reuse these tips next time for Ultem or for ABS. So modeler status, tip status. Come over and look at how much model and support material have been run through those specific tips. Oops, not too far. And once again, write that on a little Post-it note and stick it in the tip tube. Okay, so hopefully this is, not rocket science, not boring you to death yet. Unload the material. So operator control, change tips of material, and then unload the support material. Anytime we see a command in the control panel with the E in greater than less than symbols, that's going to be something that gets executed. Okay, so that's going to go through and unload the support material. So again, a picture showing the empty tubes of the tips that are currently in the machine. Okay, so once the material gets unloaded, it'll come back to that same screen. All four of the lights will be flashing. We can come in and go ahead and pull the ABS and the SR30 material out of the machine. The next step for me is I typically, get things kind of staged for the process. The two tip tubes on the left side are the ones that are currently in the machine, and the two on the right side are the ones that are going to go into the machine. Okay, and I'm going to come in, and after the material is loaded, we actually have to get out of that menu, back up one by hitting the menu button, and go over to move the head stage over, and we're going to move it to the service location. And then we've got to go in and unlock the door. So anytime the head moves, the door locks. We've got to go in and tell it to do those different things. So then, swapping tips. If you don't have a small ladder, they're very, very useful. Handy to have around. Just got to be careful not to fall off. Right? Again, on the top, I've got the tool to remove loosen the screws to remove the head. There's a picture of it down in the head. So again, this is on a 400, maybe a little bit different on some of the other machines. 2 screws, one on each side. Then we're going to come in and raise the head up and put it into the service carrier. Sometimes you're used to doing the little dance to get it up to fit it into the carrier. Get it screwed back in nice and tight. Then we're going to come in and loosen the screws to open up the heater blocks. I typically take the tips out and drop them down into the little grates in the top of the door. It's a nice place for them to get held. Let them cool off a little bit while I go ahead and put the other tips in. And then once I'm done with that process, they're usually cool enough to handle. For me, running ABS, I can typically get the tips out without a glove. When I first started, I would always use a glove. Definitely with PC, nylon, and definitely Ultems, gloves are probably recommended. A little bit warm to be handling them. And then we're going to go ahead and put the new tips back in and throw the head back into the machine. Tighten down both sides and be ready to go. Now, we're going to go back into that same menu we got into earlier for change tips of material. We've already done the first line item there. It tells us step 2 and step 3, install new canisters, install new tips. So we put the new canisters in right at the beginning. We already installed the tips. So now we can come in and select the material and tips that we want to use. Here's a picture, showing that the ABS and support material are removed. We can pull those lines on out and be ready to go. So it's going to know from the EEPROMs what material is loaded. So it's telling me it's Ultem 1010. Select tips. So it will typically have the last tips that you had in there by default. So it probably showed a T16 and a T12 SR30 because we have ABS material in there. We're going to hit select tips to enter key once. It's going to jump on over to do T14 and T16 to do a 10,000 slice. We'll keep hitting enter. It's going to jump back and forth between a 10 and 13,000 slice. The reset tip odometers is where we're going to go next, because whether these are new tips, we have 0 hours, but we've already run a little bit of material through these tips. So we're going to scroll up, enter the values for those tips, and for both the model and the support material. Select calibration part position. That's the next step. The problem is when we get ready to do this, it's actually going to want to run a job. So back to the sheet in the build area, we need to go ahead and have a vacuum pulled on the sheet, and that's why I like to throw the sheet in first. Because if we get to this point and we're just now throwing the sheet in, it's going to lengthen the time it takes to change the material. So there I've got vacuum on the left dial, up around halfway, so that's good. So now I can go back and hit, hey, select calibrate part position. If we go with the default, it places it right there in the center of the tray. I typically like to go in and use the locate part start option, move it around to an unused area off on one of the corners. So if I do have to run it a couple times, I've got a place for it. If I put one right in the middle, it's not going to use up the entire middle area of the build tray. I can demonstrate the bounding boxes that go around, but then we want to do a load and calibrate. So, switching from ABS to Ultem, waiting 5 hours and 59 minutes to stabilize the oven. So it's going to take a while. Different materials have different stabilization times, whether you're switching from ABS to PC or nylon or PC to Ultem. But it accounts for any growth that the thermal expansion that the tray may have when it calibrates. So we'll wait another 6 hours in the presentation. Blah blah blah. At the time, got some music playing as we wait and wait and wait. But let's say we sped through that 6 hours and I went ahead and calibrated. So I've got operator control, calibrate, and the tip offset value. So if any of you guys have ever read a calibration plot, it wants us to come in and put the values in to the tip offset values. For a 900, some of the other machines that have the touch screen, that's a little bit different process now, but about the same idea. If we've seen this print once, we've probably seen it a few times. We've got a bead of plastic in between the two rows here. We want to find the value where we are centered up nicely between the two sides of the rows. Okay, punch those values in. If they're a ways off, we may want to go ahead and rerun the calibration job. We also need to measure the thickness of the top center bead in this middle rectangle, and we want to shoot for the 10,000ths or 7,000ths height. I typically like to be between 10 and 10.5 for the value. Seems like that works best for me. If we do have to come back into the operator control, rerun the calibration job, we can just do that same process over and over again until we get it nice and calibrated. So a couple sample parts here. I've got one of the parts cleaned off, and a little bit of support material still left on the bottom of this little flange. Kind of see how they pulled off of the tray. One came off nice and neat, the other not so much. Now I left that support material on the left part until it cooled, and like I said earlier, it became very rock solid and very difficult to come off when it wasn't at a warm temperature. Take a look at the build sheet as well. The material is left on there. When I went to go put this back in the machine to run another part on this same tray, you can kind of see the support material kind of pulled up and bubbled up. on there. That added a little bit of extra stiffness to the sheet, and it was a little bit difficult to pull a vacuum. So I ended up getting it to pull a vacuum, but I needed to pull some of that support material off of there. So I left it in there nice and warm for a little bit and was able to get it off the sheet fairly easily. When you're removing the part from the build sheet, the sheets here, they're a bit thicker. I have seen some cases where the sheet actually cracked and broke. Once that happens, you're not going to be able to pull a vacuum anymore. So some pictures of the parts as it's running. The gold material for the model material, the support material is also kind of a gold material. Kind of see it there in the pictures. Little support towers up there for the overhangs. Okay, so this one's kind of fun. There's a little bit of support material down in the tubes. There's a little bit more detail even on the inner side that I had to probably stick the part back in the oven 3 or 4 times probably. Let it warm up, get the pliers after it, get it pulled off. Another mating part for that same one. We'll see these parts show up here in a little bit, and the kind of finished picture. Okay. Now, as opposed to the Ultem 9085, which is available in a gold and a black material, right now the 1010 standard material is only available in this a little bit brighter gold, I would say. So these parts were actually for the University of North Texas Formula SAE race car team. Some pictures here of those parts actually mounted to the engine. They're actually going to be doing some dyno testing here in the next couple of weeks. So this is an engine off a CBR 600 F4i. So everything's stock right now. They designed and built the intake and exhaust. Everything they're seeing from the flow analysis, they actually ran some SolidWorks flow analysis on it. Saw a 12.5% flow increase over the stock unit. They'll see how the dyno testing goes coming up. So support removal. A lot of times I'll stage things before I get started. A pair of gloves, knife, pliers, a poker, a hook. So we can kind of see the side picture of the support material there. You see little striations about every 1/4 of an inch. What happens is, instead of building just all support material, every so often they put in what's called a perforation. You can actually do this with your ABS material if you want to, inside, but it puts a layer of model material in. So the support towers kind of break apart on those natural fracture lines. Makes things a little bit easier to clean up. So that's kind of nice. So there's another picture of the part. The part that's also on there with them, I definitely oriented it so that there would be minimized support material. There's just a little bit around the base where it attaches to the sheet, and around a few little posts there. That cleaned up, fairly easily. Looking at a little bit of material properties, there's a lot of little dots going on here. When I first saw this, it took me a while to figure out what was going on here. So from left to right, we've got a higher impact strength. So we can see the nylon and the PC ABS are fairly good. The 9085 is a little bit brittler, we'll say that, than the ABS. The Ultem 1010 is a little bit even more brittler as we go down the chart. It's very, very strong, but when it fractures, it tends to break along the lines. So I got a pretty good impact strength. Where we like the 1010 is the temperature rating that it can go to. So the Ultem 9085, the heat deflection temperature in the 350° Fahrenheit range, where 1010 is in the 420 range, so quite a bit hotter. So some of the differences there, the 1010 like I said, it doesn't elongate or stretch when it breaks. It's more of a fracturing tensile strength up another, say, 1,000 psi tensile modulus. Again, very, very rigid, but not as impact resistant, so more impact sensitive. Temperatures, cranks it up there, heat deflection, and they've got it at that temperature with a certain pressure load on it. Certifications, the FST's smoke and toxicity rating for the material. That's the nice thing about Ultem 9085 that makes it so friendly with the aircraft industry. You know, it can fly. Typically, people still are having to do, you know, burn coupons to prove out the process. The material is good. It's just the printing process, getting it certified. The Ultem 1010 does add the biocompatibility and the food contact option when it takes it up a notch. So again, Ultem 1010 versus 9085. 1010's higher strength and temperature, chemical resistance, and different certifications. Now the Ultem 1010 is actually available in two different versions. There's a regular 1010 and then an Ultem 1010 CG certified grade. So what that does is it goes through more stringent packaging and controls to help get it classified. Now, Ultem 9085 is still tougher and more flexible, impact strength. So certain things that are going to take a collision, maybe you go ahead and stick with the 9085. So here's kind of the range of the materials that are currently there. So PPSF is always the top of the line, you know, chemical resistance strength material. 9085 was just below that, but now 1010 kind of overlaps both of those ranges in the in-use part category. So one last thing I'll throw in here. Talked about the heat, operator control, temperature control. There's a couple options you can do with the parts when they're done printing. You can actually have the temperature come down and automatically cool down when the part is done. So for us, if we're printing it on the weekend, I'm not going to be back in until Monday morning. I don't typically want to leave the printer warm at 225 degrees C all weekend. So I can actually cool it down to the 175 when the job is done. If I know that I'm going to come in and take the part out, say this afternoon, I typically don't want the oven to cool down. So I don't want to have to warm it back up in case I ever need to throw the part back in there to remove it. Another thing, let's say I'm ready to switch from Ultem back to ABS or nylon or PC. What's the first thing I did on the PowerPoint? I threw a sheet in. Okay, if I throw one of the thin ABS sheets into the build when it's up at 225 degrees C, it will do bad things. It's going to melt and wrap around the tray and be quite possibly difficult to remove it from the machine. So before we're going to come in and switch to a cooler material, definitely cool the oven down. That also cuts down on the thermal expansion, 6 hours that we saw earlier. If it's already cooled down, then a lot of that time is going to be already used up in the cooling off of the machine. Okay. So just a little bit, GoEngineer. Hey, we try to be a full service company to help with design and manufacturing tools. Try to share some of our expertise and things that we've worked with and experimented with. We'll take a challenge on. We'd rather us do it on our machine and instead of you guys, experimenting it on your machine. Experimenting is always fun, but whether it comes down to SolidWorks or stress analysis or 3D printing side of things, we've got experts out there that have been doing this for years and years. there's my email address, Tony Riggs at GoEngineer.com. If you've got any questions, definitely let us know. We've tried a number of different things. So you may say, hey, I've never done that before, but I'll try, or let me ask Stratasys. More than willing to do that. You've also got a ton of different YouTube videos out on youtube.com/GoEngineer. We've got some videos out on our website as well. Another question that people ask me all the time, and I want to get out of the PowerPoint and bring up the internet real quick. And I'm going to move it over here. Let's go over here to www.stratasys.com. How many people have ever been out to the Stratasys website? I'm always getting questions about materials. Right here from the top toolbar here, we're going to come in and let's look for information about Ultem or nylon. Okay, it's going to give us information about that. We've got the spec sheets, material guides. It's about a 6 or 7 page document on, here's some steps, support removal, different ways we want to orient the build to get the best end part. Okay, which way do we orient the job? Which corner do we start in to be the best? A couple of different case studies as well. So all kinds of great information about different materials that are here on the Stratasys website. And definitely, if you can't find something you're looking for, let us know, and we will try to get an answer for you. So that's about 30 minutes. That's what time we had scheduled for this webinar. Like I said, it's a little bit different than maybe some of the ones that we've done before. A little bit of a process of working with the machine. But does anybody have any questions? Well, I don't see any questions popping up. But again, my email address, triggs, T-R-I-G-G-S at GoEngineer.com. If you need anything that we can help with, we will give it a shot. And if you've got any other ideas about any other 3D printing, rapid prototyping webinars that you'd like to see, shoot that to us as well, and we'll try to get those scheduled up. So again, this is Tony Riggs with GoEngineer, and thanks for joining us.